Hi guys, we are talking about inverse trig functions. I have to say that this is probably a topic that students do find difficult simply because of notation, I would say. To be able to find an inverse function, we know that the function has to pass a horizontal line test. Meaning, if I draw a horizontal line through the sine of x, I should have no more than one crossing point. We know that this is not the case with the regular function, as there are plenty of intercepts that repeat every pi intervals. So in order for an inverse function to exist, we have to chop off only a part of our original function, and then we can find its inverse. So the sine of x has an inverse function on this interval. Let's go ahead and write what the interval is. The only place that sine of x has an inverse function on is the interval of negative pi over 2 up to positive pi over 2. So if you think of the unit circle, let me pull that up. If you think of the unit circle, the only place that sine will have an inverse function is this part of the unit circle. Only between negative pi over 2 up to pi over 2. This is also part of the definition of our inverse trig functions that I'm going to talk to you in just a minute. Having to find the inverse trig function, we are really going to get the angle instead. So inverse trig functions return the angle. So far, we have been thinking of the trig values of a certain angle. Say pi over 2 or 90 degrees. This angle right here. If I asked you to tell me the sine of pi over 2, you can read the y-coordinate and tell me that it is equal to 1. If I am asking you to tell me the inverse trig function, then I would tell you, knowing that the sine is equal to 1, or sine inverse of 1 is equal to how much? As I said, the inverse trig function returns the angle, and we know that the angle when sine is equal to 1 is pi over 2. Okay. So let's look at an example. Another thing to know here, let's go ahead and add that on our notes, is that the inverse trig function, the inverse of sine, there are two ways to say that. You can either write sine inverse of x or the arc sine of x. Those two notations mean the same thing. It means the inverse of sine. Okay, let's take a look at an example. Arc sine of a negative square root of 3 over 2. What that really means is, what is the angle when the sine is equal to negative square root of 3 over 2? We're just looking at these two quadrants, the right part of our unit circle, and the y-coordinate is equal to negative square root of 3 over 2 down here. What I can see from there is that the sine of 5 pi over 3, or negative pi over 3, is equal to negative square root of 3 over 2. Since negative pi over 3 is in the allowed interval, then the arc sine of negative square root of 3 over 2 is equal to negative pi over 3. Let's take a look at the next example. For the next one, we have to find sine inverse of 1/2. Or, what is the angle? Sine of what angle is equal to 1/2? Let's go back to the unit circle. It certainly looks like the sine of pi over 6 is equal to 1/2. Since pi over 6 is in our interval, then sine inverse of 1/2 is equal to pi over 6. And let's take a look at the last example. We're asked to find the sine inverse of square root of 3. Or, what is the angle that results sine of what angle is going to be equal to square root of 3? Well, wait a minute. Square root of 3 is greater than 1, isn't it? If that is the case, there is no angle that will result in a sine of square root of 3. That means that sine inverse of square root of 3 is undefined. I'm going to pause for a moment to move this unit circle, and we'll take a look at cosine of x and when cosine of x would have an inverse function. With cosine of x, if we limit the domain to be from 0 to pi, then this part of cosine would be able to pass the horizontal line test, and the inverse will exist. So let's go ahead and add that the cosine of x has an inverse function on the interval between 0 and pi. So when we look at cosine, to be able to find the inverse function, we are only going to look at the top part of our unit circle. Once again, there are two ways to write this inverse function. One way is to say that we're looking for the arc cosine of x, and it is the same thing as the cosine inverse of x. Please note, cosine to the negative first power of x is inverse and not reciprocal. Let's take a look at our first example. We're supposed to find the arc cosine of negative square root of 3 over 2. Or we need to find an angle whose cosine is equal to negative square root of 3 over 2. Since we're looking at the top of the unit circle, the negative square root of 3 over 2 would be in quadrant 2. An x-coordinate of negative square root of 3 over 2 happens right here, and this is the angle of 5 pi over 6. Since the cosine of 5 pi over 6 is equal to negative square root of 3 over 2, then the arc cosine of negative square root of 3 over 2 is equal to 5 pi over 6. Another way that we can talk about this is an angle whose cosine is equal to negative square root of 3 over 2. For the next problem, B, we have cosine inverse of 1/2. What is the angle that has cosine of 1/2? Well, since the cosine of pi over 3 is equal to 1/2, then cosine inverse of 1/2 is equal to pi over 3. We can do the same thing with tangent as well as sine and cosine. For the tangent of square root of 3 over 3, we're really asking ourselves, what is the angle whose tangent is a negative square root of 3 over 3? Well, let's take a look. Negative square root of 3 over 3 is the same as 1 over square root of 3. We find tangent as y over x. So negative will be in the second. For the negative part, actually, we will be looking in the right part of the unit circle for tangent. negative square root of 3 over 3 will happen right here. This will be negative pi over 6. Since the tangent of negative pi over 6 is equal to negative square root of 3 over 3, then the tangent inverse of negative square root of 3 over 3 is equal to negative pi over 6. So this is how we would evaluate inverse trig functions. I want you to pause the video and please read the definition of the inverse trig function. Note that each one of these functions has a different domain and then different range. Now let's take a look at example 3. We have to use a calculator to approximate the value if that is possible. We're asked to find the arctangent of 1.9, or we're looking for an angle whose tangent is equal to 1.9. Note that 1.9 is in radians, so the first thing you need to do is make sure that your calculator is in radian mode. So when you click mode, make sure it is in radian. If that is the case, then you are ready to evaluate this. You would click on second 10, that's going to be the tangent inverse of 1.9. When you evaluate that, it gives you an answer of 1.086. Automatically, the arctangent of 1.9 is equal to 1.086, rounded to the nearest thousandth. To do the next example, we have sine inverse of negative 0.919. Second, sine takes you to sine inverse of negative 0.919. The calculator says that the angle whose sine is equal to negative 0.919 is negative 1.166, rounded to the nearest 1,000th. Now for the last example, we are to find the arc cosine of negative pi over 3. Or we are looking for an angle whose cosine is equal to negative pi over 3. Let's see what happens when we put this in the calculator. Remember that arc cosine is the same thing as cosine inverse. Maybe we should write that in our notes. This is the same thing as cosine inverse of negative pi over 3. Second cosine gets you to cosine inverse of negative pi over 3. Oh, wait a minute. That gives us an error. And it says that the error is in domain. This means that the cosine inverse of negative pi over 3 is undefined. And the reason for that is negative pi over 3 is really like negative 3.14 divided by 3. It is a number less than negative 1. And we know that the values of cosine are only between negative 1 and 1. That means that we're really looking for a cosine that doesn't exist. The angle of a cosine that does not exist. Which is why this arc cosine is undefined. I'm going to pause right here and we will do the back of our notes in class. Inverse trig functions definitely require some thinking. We will spend the whole day in class on practice of that topic. I hope you guys have a good Halloween or had a good Halloween. I'll see you tomorrow.